To host Drupal on AWS. My name is Brian Thompson. I'm the Director of Web Engineering, a company called Mindgrub. We're based out of Baltimore, just north of DC, right down the street from Fort McHenry. I thought I would be leaving 32-degree weather behind to come to sunny Florida. On Friday, it was 65 without a cloud in the sky. My coworkers were quick to remind me, though, that tomorrow it's supposed to be 32 degrees, and on Monday they're supposed to get 6 inches of snow. I'll still be here. It's a rough life. Been working in web tech since 2006. I'm an AWS certified solutions architect. I'm on Twitter. My coworkers always like to have competitions about how many Twitter followers I pick up when I go and speak at conferences. Currently the record is 7. So that's the bar to jump over at Florida Drupalcamp 19. When I'm not working with tech, I'm also a baker. I like to make sweets, and I tend to go outdoors and try and get as far away from technology as I can in areas with no cell phone coverage so people can't call me or talk to me or see what I'm up to. Wonderful. So, as many of you might have experienced if you're working with websites and you have clients who are talking to you or even just other business stakeholders, oftentimes they like to throw out this phrase, we want to use the cloud. Because the cloud will solve all of our problems, and we'll just host it in the cloud, and we don't want to use a managed hosting provider like Pantheon or Acquia, because that's not the cloud. And as you dig into it, having dug into it all these years, what they're really saying is we want to use AWS, because in their mind, AWS is the cloud. That's where they want to be. They believe that if they use AWS, they will be infinitely scalable, they will have no problems, everything will work fine. And so as you just get started in all of that, and you're like, okay, I need to host my Drupal site on AWS, maybe you've used DigitalOcean before or Linode where you can configure your virtual servers, how much different can AWS be? It should be relatively simple to host some sites there. And so you log into the console for the first time, and you see all the different things that AWS offers as a service. You'll notice in this screenshot that it's actually clipped at the bottom because I couldn't fit it all on the slide. And so you wonder, which of these am I actually supposed to use to best host my Drupal website on AWS? And you're looking at it and you're scratching your head and you're like, machine learning, all right, that's probably not us. We can scratch that category out. And you start to go through the different sections trying to figure out how you can best set your client up for success so that you can be that outdoorsman, you can go away from all the cell phone coverage and you don't have to worry about their site going down and them trying to call you when they can't. So we get posed with this question, where do we start? The very first time we were trying to host a website on AWS, how do we actually go about doing that? And so if we boil it down and we try and start this simple, doing what we know, all we really want is a server. Virtual private server that we can configure, throw Apache on, maybe throw MySQL along with it. How hard can it be? And for those of you who have messed, by show of hands, how many people have messed with Amazon EC2 servers before?
I've never gotten past that screenshot.
Okay, fair enough. I know the feeling. I have some coworkers who are like, where's the operations team? If you've ever messed with Amazon EC2 servers before, you know that the first step to spinning up an EC2 server is defining your VPC with network blocks and subnets and doing a bunch of extra networking things, which generally as a web developer is not what I'm looking to do. I just want my server, I want it to have an IP address so that I can update my DNS, and away we go. So if you're looking to start with AWS, you're trying to get a server up and running and you're equating it to DigitalOcean, what I would recommend is the best place to start is with Amazon LIGHTSAIL. Amazon LIGHTSAIL can most simply be described as keeping servers simple. And if you pull up their webpage on aws.amazon.com, that robot actually waves back and forth to you, trying to teach you how simple it actually is. But the good news is that you can think of Amazon LIGHTSAIL as virtual private servers, just like you have on DigitalOcean, Linode, any of the other fairly simple hosting providers out there. And you don't need to worry about managing security groups, networks, defining network access rules, or any of the other AWS stuff that has been around since 2006. And while slides are great, why don't we just jump into it? So, that's not what you see.
Can we turn the lights down?
Yes, I will grab the lights in just a second. How's that? Better? Cool. All right, I will work backwards here. So, when you first sign into AWS, this is what the management console looks like. And here's that services screenshot that you saw before. You'll notice it scrolls on and on and on. And it can be kind of daunting. And trying to find LIGHTSAIL, if you don't know where to look, it's a little tricky. So one of the first recommendations I actually give to people if they're using AWS for the first time is up here in the right-hand corner. You can change the way it lays out this page. And you can change it to alphabetical instead of grouped by categories you might or might not know where things fit. And so, because LIGHTSAIL is an L, I can scroll down and find it here. You can also search, and their search is actually reasonably decent. So I can just type in light and find LIGHTSAIL, and it launches this other console here. See if that helps with hearing everybody in the hallway. So, when you first get to Amazon LIGHTSAIL, you'll notice that it's telling you have no instances, but there's a big button in the middle of the screen where I can hit Create Instance. And not only can I start, but I can also say, hey, I want to install Drupal and have it pre-configured for me. Maybe I don't want to go to its level of configuration. Maybe I'm comfortable installing Apache, installing PHP along with it. So I can pick the OS-only version if I want and go the Ubuntu route. Or I can go App plus OS, your choice. My preference, being partially a systems administrator person, is to take just the bare operating system and install it myself. But both are available for you. I connect via SSH, so I can change and upload a key pair if I want. That would be my private or public SSH key from my local machine. Amazon will also generate one for me if I don't provide it and give me the details about how to use it. Very simple. You can see I have a download option here. And then I get into the pricing and sizing plans. You can see at the smallest size here, it's only $3.50 a month. Relatively cheap. Half a gig of RAM, 1 CPU, a terabyte of bandwidth back and forth, 20 gigs of disk space. This actually might be a semi-reasonable development server if I'm just working one and I need a place to work in the cloud. But I can also take and pick a bigger one if I want to. Only $20 for 4 gigs of RAM and 2 CPUs. I can name it. Let me just add a FLDC 19 here. And I can add other tags if I want, but normally I just leave them blank. And I hit Create Instance. And Amazon will go ahead and start provisioning that for me so that I have that. Now this is all good, but we all know one of the first steps in scaling Drupal sites is to separate the database from the actual web server. How many people have built highly available database clusters that are replicated between servers? One? I would advise you not to. Generally, configuring MySQL beyond a couple of initial configuration tweaks and getting synchronization back and forth can be a hassle and a time suck. So I can also switch over to this database tab, click Create Database. They offer MySQL. I have 3 different versions here depending on which I want to use. And I can choose whether I want a standard database or a high availability database. High availability meaning AWS handles the failover, it's replicated for me. I don't have to worry about my database server going offline in case of an outage or hardware failure or something of the sort. And again, I can just pick simply based on sorting by price, or I can resort by memory based on how much memory I need. I can give it a name, and I can hit Create Database.
I have a question.
Yes, sir.
Can you resize it once you've created it, or no?
You can go up, you can't go down.
Okay.
So Amazon will always let you buy more. They are not very keen on letting you buy less once you start to pay for
You
it.
can do it dynamically, like you can, and can you do it via API?
Amazon LIGHTSAIL does have an API. I have not messed with it, but I think I have better options for you further in the talk.
All right.
So there are a couple other options here. If you want more storage, I can add additional disk space to it, but we'll let those do their things. You can see it's already configured here. Even without downloading the SSH key, I can actually launch a connection into that. So I can go ahead and I can sudo apt-get update just to update all of my source repository things. And then as soon as this finishes here, I could go ahead and start installing Apache as part of all of this, if I spell the command correctly. So at this point, I'm off and away configuring my server, getting ready to put Drupal on it. And that's all well and good, but if we're really hosting Drupal effectively, we're missing a few things with all of this. It's a great simple setup, perfect for those small sites that maybe don't need a whole lot, but there are a couple of pieces that are missing. And in order to figure out what exactly we're missing as we're starting to use AWS here, one of the references that I like to point to is what AWS calls the well-architected framework. This well-architected framework is something they've come up with, they've published online, and is a set of 5 pillars of application design and a checklist of design principles to make sure you're using the cloud most effectively. That's what they found working across hundreds of thousands of different customers, be it Airbnb, Netflix, Acquia, any of the sort, for how to best use the cloud and even more specifically their platform. And so as we dig into those 5 pillars, we see that they cover all sorts of different sections of it: security, reliability, performance efficiency, cost optimization, and operational excellence. From a security standpoint, we're looking at applying security at all of the different layers. In our Amazon LIGHTSAIL instance, we don't have to worry about that. Amazon manages it for us, but we're talking about who can actually communicate with the database. Is the database available for connection anywhere? Can I connect to it from my laptop here? Can I connect to it from my smartphone? Or is it only available for connection from my Amazon LIGHTSAIL servers? Implementing principles of least privilege. I got access to that server and I immediately had root level access. You saw that I was able to sudo apt-get install Apache. If I just pass that key pair around that it had generated for me, everybody I give that to, other developers, maybe my client or whoever is actually owning the website, now has full access to the system. Is that something they need? Making sure we focus on securing our system, not just the Drupal site, but if we're managing servers or managing the cloud to host this website, making sure we focus on it and automating it where we can. On top of that, we talk about reliability. This is the second pillar. Making sure we test recovery procedures. What happens if that LIGHTSAIL server experiences a failure? The SLA for Amazon LIGHTSAIL is, I believe, 99.9%. That means you're going to have a couple of hours of downtime over the course of a year. It's built into the 99.9. Even at 99.99, you're still talking, at least I think off the top of my head, 15 plus minutes of downtime over the course of the year. Is that acceptable to you? Is that acceptable to your client? Maybe it is, maybe it isn't. I know from my experience, even when the client says, oh, that's okay, I'm still the one who's fielding the angry phone calls when their site is blipped offline. I'm an outdoorsman. I like to be away from technology as much as I can, turn off my cell phone or just flat out not have cell phone coverage so that people can't get in touch with me. Can I automatically recover from failure so I don't even have to get involved? I'm presenting a talk right now. If this Amazon LIGHTSAIL server were hosting a Drupal website and went offline, it would probably be at least another, I think I've got 27 minutes left in this talk, before I can switch over and start provisioning the next server. And that's not counting the time it's going to take me to reinstall Apache, reinstall PHP, pull down the code to it, figure out where my Drupal files were stored, do I have a backup. Talking about scaling horizontally, we could certainly increase the size of our LIGHTSAIL server from 4 gigs of RAM to 8 gigs of RAM, but do we actually need that much? Or are we better actually having 2 4 gig servers, 4 gigabyte of RAM servers instead, so that if one fails, the other one can keep picking up the load? And really the hardest part about reliability, capacity. I think we've probably all had those people who believe their site is going to go viral the day it launches. Some of them might come close. Most of them, I think, in my experience, do not. And we end up over-provisioning quite a bit to be able to handle a potential theoretical load. Over-provisioning means overpaying, means people have to pay for those virtual servers. It costs the client a lot more. A number of years ago, back in 2012, I had a client who was prepping for their website to be featured during a benefits concert. A number of A-list celebrities, Beyonce, Sarah Silverman, and others were going to be on TV in prime time on Sunday night pushing people towards the website. We provisioned a bunch of servers for them. We over-provisioned a bunch of servers for them to make sure that they could handle the load. In the end, they didn't need the total number of servers we provisioned. It cost them quite a bit of money. So figuring out how we build in capacity planning without having to guess at it as we go along as a pillar of application design. That builds into performance efficiency, utilizing advanced technologies where we can, leveraging things like auto-scaling, automatically adding instances, handling failures automatically, being able to go global. We just built that Amazon LIGHTSAIL server in their Ohio database. What happens if a snowstorm hits Ohio that takes the data center offline and I need to shift the entire operation to AWS's Northern Virginia data center? Or the East Coast gets hit with a hurricane and I need to shift things to the West Coast or move things over to Europe? How quickly can I actually go global and move my load around? How often can I experiment? If I have to manually configure servers every time, then running experiments to see if I get better performance out of more CPU cores but the same amount of RAM is very difficult. And the last part with mechanical sympathy goes back to the adage of how much you care about your server. How many people have pets? A few people. Everybody likes their pet, right? We're very attached to our pets. Our cloud servers should not be our pets. If my server goes away, that's okay. I don't care. The next one will come in. If my dog goes away, I will be quite sad. So, where I host my websites are not pets. Instead, we refer to them as cattle. Where we have a large number of them, I bring in more cattle as much as I can. The fourth pillar is cost optimization, making sure that we're delivering the most value to our clients as they try and host their websites. Trying to adopt a consumption model, only paying for what we use, not having to over-provision, pay for more than that. If we can get to the point where we only pay for exactly what we're using, then we've reached the true optimization of cost because we haven't spent a penny more than we need to. Benefiting from economies of scale, leveraging the fact that AWS runs millions of websites, has hundreds of thousands, if not millions, of databases on it, and they already have a team of people who have figured out how to replicate MySQL in a master-master configuration across multiple data centers. Like I said earlier, if any one of us were to try and sit down and do that, we would be talking days at best. Having done it before, I can tell you, I worked it for 3.5 days, had it mostly working, but lived in fear that it was going to break and not go well. Much easier to leverage economies of scale where Amazon can have the people and expertise to do that for you. Making sure we're analyzing expenses. AWS will break the bill down to exactly how many pennies you're paying for your servers, for your database, for your bandwidth, for your data transfer, and understanding what we can leverage to try and reduce those costs. And again, using managed services where AWS manages the infrastructure, reducing total cost of ownership, not having to worry about patching my servers. What happens if Heartbleed comes out again tomorrow and I have to patch that Amazon LIGHTSAIL server I just pulled up? The last pillar in the well-architected framework is operational excellence, trying to perform operations with code versus connecting to a console and running my install commands myself, being able to make regular, small, incremental changes. We mentioned a few slides back being experimental and seeing how we can work and conduct small experiments. By putting that in code, we can actually do it quite quickly without having to spend time configuring all of that. Testing for responses to unexpected events. What happens if a data center goes offline? What happens if, for some reason, a fiber line that connects the east and the west coast of the United States gets cut as somebody's doing construction? All of these things you don't think you have to worry about. But I can tell you, having sat on a number of email mailing lists about network operations across the United States, fiber optic lines get cut more frequently than people realize, and especially critical ones that run from east to west or run overseas. Learning from operational events and failures and keeping our operations procedures current. What are you going to do if the server goes offline? And so with all those pillars, and we sort of make our checklist here against Amazon LIGHTSAIL, or AWS LIGHTSAIL, we've got security, for the most part covered, partially at least. I think anybody can still SSH into my AWS LIGHTSAIL server from wherever they were. So if you were trying to run an attack against me and you were trying to guess a password or try and just brute force your way in, I'm not blocking those connection requests on port 22. If you happen to grab the IP address of the server from back when I had the demo up, maybe you're trying it now while I'm up here talking. That server won't last long after this talk. From a reliability perspective, again, it's partially there. Spinning them up, it'll spin in new ones as needed if the first one fails, but it's not going to reconfigure it to install exactly my site on it. I'm still going to have to go back in, install Apache, install PHP. If I'm not using the database separately, if I've installed that manually, I'm going to have to do that.
And it's not taking backups, right?
It's not configured to take backups out of the box. There is a snapshots option which will do backups for you, but I didn't dig into it, and it's not configured out of the box for you. Amazon fully and wholeheartedly puts backups as your responsibility. So if you didn't configure it when you were setting up your Amazon instance, assume that it's not happening. And assume that you'll learn that the hard way at the time that's least opportune for you. Performance efficiency, cost optimization. We had to guess as to how much we needed. How big of a database did we need? How many queries were we going to handle? How much RAM did it need? How much RAM did our server that was running Drupal need? We say that Drupal's memory limit out of the box is 128 megs. Normally we end up pushing that up to 256 because 128 is like kind of pushing things for Drupal, at least in the Drupal 8 space. How many requests can I actually handle, or am I going to receive that? That's a lot of math I don't want to have to do because it doesn't handle the fact that somebody might get tweeted about their site and all of a sudden have an influx of traffic. Not doing really well there. And we were configuring it all manually, so we've lost out on any operational excellence. So we can do better. One of the first ways we can do better is using a product that AWS has called AWS Elastic Beanstalk. This is the icon for AWS Elastic Beanstalk. AWS has really strange icons. Their DNS icon is actually just the two pillars sticking off backwards. Why they're like that, I don't know. But I second guessed this icon when I first put it in this presentation. Don't worry about the icons. Like I said, it is very elastic. Sort the drop down by A to Z, and you'll find it in the E section. AWS Elastic Beanstalk is an easy-to-use service. These are their words, easy to use. Service for deploying and scaling web applications, supporting Java.NET, Node.js, Python, Ruby, Go, and for us, PHP. which is really the most critical when we're talking about a Drupal website here. It also is compatible with Apache, Nginx, IIS. It will do load balancing for you. And it does all of this at no additional cost. So I don't have to pay any extra for all of this. I just pay for the servers that are provisioned, the database, so forth. It handles capacity provisioning for us, meaning that it will automatically set up auto-scaling rules to monitor the load on the servers it has provisioned, and if I need more, will automatically add more for me. If my servers are sitting idle because I've over-provisioned, it will scale them back and start to take them away. I don't have to worry about that. I don't have to set it up. Having set up those rules manually before, it's probably a good couple-hour task of going in and setting them up, testing them to make sure they work correctly, figuring out where your application is going to need to scale first. Are you going to get constrained by the CPU? Are you going to get constrained by the amount of memory you have? Are you going to get constrained by the amount of bandwidth? AWS Elastic Beanstalk handles all of that for you. It also handles all of the health monitoring, and so it will automatically replace instances when they fail. It will automatically patch instances, do your security updates, all without having to touch it once you set it up the first time. Even better, they actually have an Elastic Beanstalk tutorial for building a high availability Drupal setup. And we'll dig into it in a little bit here a few slides later. But I will post the slides afterwards. I will add them to the session node on the Florida Drupalcamp website, and I will also tweet them. So you can follow the link. It also comes up if you Google search AWS Elastic Beanstalk Drupal. It will walk you through every step of the process to be able to get it set up. It'll probably take you about 20 minutes. In order to be able to host using Elastic Beanstalk in this high availability architecture where we have multiple servers, one of the things we have to worry about is file storage. Drupal has the site's default files directory for user uploaded files. If we have multiple servers, somehow that directory needs to be shared between all of them. In November of 2017, Amazon came out with a product called AWS Elastic File System. They gave it this nice elastic blocky pyramid icon. What you should know is that everybody calls this EFS because Elastic File System is way too much to say. It is essentially Amazon's managed network file system. No different than if you have a Windows share, if you're at a Windows shop and you're sharing a folder back and forth, or if you're on Linux and you've created a Samba share. It's available for you to be able to go out and connect to multiple servers and have one place to drop your files. It automatically handles capacity provisioning, which means I don't need to tell it that I need 10 gigabytes or 40 gigabytes or 100 gigabytes. I pay for what I use, and it just charges me per gigabyte of files stored. I can start very small as my site launches. Maybe I only need 2 or 3 gigabytes. After a year, I'm using 30 gigabytes. I never had to touch it. It automatically just scaled up the amount of storage available to me without having to interfere with it. In addition, just earlier this week, Thursday I believe, they introduced a new feature for it, which managed to make it into the slide deck here. This is called lifecycle rules. And so if you enable lifecycle rules when you're creating your Amazon EFS drive, it's a checkbox to check, what it will do is take files that haven't been accessed for 30 days and charge you less for them. And you just pay less. Files that have been accessed within the last 30 days, you pay more for. It's one checkbox, but the idea is to provide cost savings for infrequently accessed files. You can see standard storage, I'm paying 30 cents per gigabyte per month. That's replicated 6 ways, so it automatically handles failure as well. I don't touch that file for 30 days. Maybe it was a user uploaded file that we've never looked at or nobody's worried about, or it's old aggregated CSS files that didn't get cleaned up. After 30 days, I only pay 4.5 cents per gigabyte, 25 cents per gigabyte savings. There is one thing to watch out for. Not only, while I am getting a cost savings in terms of storage, I am paying 1 penny per gigabyte transferred to actually retrieve those infrequently accessed files. So total, you might be in for 5.5 cents per gigabyte if you have that file that's infrequently accessed and then it becomes accessed. What you should know though is that once you access an infrequently accessed file, it moves back to the standard storage. So you stop paying that infrequent access request charge, and you start instead paying the 30 cents per gigabyte per month. The other trade-off for infrequent access storage is performance. For your standard storage, those that you're paying 30 cents a month for, Amazon guarantees single millisecond read times for those files. So that's 1 to 9 milliseconds. If your file is in the infrequent access storage, then they guarantee 2-digit millisecond response times, up to 99 milliseconds. 99 milliseconds, in my opinion, is still pretty fast. For a 25-cent savings, I'll take the extra 80 milliseconds of response time that first time to be able to pull it back, to be able to pass cost savings along. So now I've got my file system taken care of, automatic, don't have to worry about capacity provisioning. The next piece to sort of figure out in all of this is the database. We saw that LIGHTSAIL had a database option. Amazon as a whole, in their more complex offering, if you will, also has a database option. Yes, sir.
I wanted to kind of go back to the file system slides that you had earlier.
Yep.
How does this compare to the setup that you had previously demonstrated with LIGHTSAIL, and then perhaps using like a content delivery network for the sites default folder and stuff like that?
Sure. So how does AWS EFS compare to what we had for AWS LIGHTSAIL and using a content delivery system with it? So with AWS LIGHTSAIL, all of the file storage that you get is local to the server that you provision. You don't have shared storage across them. So if you do try and scale from that regard, you're going to have to find another alternative for keeping those files in sync between AWS LIGHTSAIL servers. I've seen people do some interesting things with rsync and having that run through a daemon that copies files back and forth. I'm not a huge fan of it because it's more configuration I have to do, and I've always found it to be temperamental. From a content delivery standpoint, you can also use that to sort of provision things out, but that's really more for serving files to users quicker than it is for sharing files across multiple systems. It's a different way of sort of scaling to handle things.
Plus, if that server goes down, you've lost the
You've
local
lost
storage.
Exactly.
Yeah.
Yep. From a database perspective, we have what Amazon calls their AWS Relational Database Service, which we abbreviate sometimes to RDS. They call it their cost-efficient, resizable relational database. It offers a number of different flavors of database. Not all of them are even listed here, but they do Oracle and MS SQL and a whole bunch of other stuff. The ones that we're really caring about are that they offer MySQL, MariaDB, or the one you probably haven't heard of as much, Amazon Aurora. Amazon Aurora is their fork of MySQL. It is MySQL compatible and compliant with all of the standards, but they've built additional redundancies and scalability into it. At this point, if you are using Amazon Relational Database Service, RDS, I would recommend you go with the Aurora product because it will handle some capacity scaling for you. And it's been optimized and tuned to run in the cloud without you having to mess with it. From the AWS Aurora side, there are two different versions that they offer at the moment. One is called Provisioned, where you specify how much CPU and RAM you want. The other version is called Serverless. If you're familiar with Serverless from maybe AWS Lambda or functions that run, the database product is the same way. It's a very similar database technology to what Pantheon has been using for years, where their database containers spin down after a certain amount of access, non-access, and then one first request spin back up. Following the sort of pillars of architecture, AWS RDS Serverless automatically scales disk space, CPU, in memory for us based on requests coming in. You pay only for what you use, and it will start in less than 30 seconds. So if you've got a development site or even a production site that has very variable traffic that you don't want to over-provision for, this is a great solution for you. This is one of the tools we use, especially on our dev sites where people aren't accessing them over the weekend or overnight. It actually spins back overnight to 0, charges us nothing. Then in the morning, whoever the first developer is who hits our development site or test site wakes it up and we just start paying for what we're using. All of that combined together makes for a fairly highly available stack. So let's see what that looks like. All right. There we go. I'm going to close out of the LIGHTSAIL stuff here and jump back over to the AWS console. Because I'm sorted A to Z, I can find Elastic Beanstalk here in the E section. And I'll pick Elastic Beanstalk. And you can see I actually already have one set up here to demo. But I'll go ahead and click Create New Application. I can give it a name, FLDC Live Demo. I can call it if I want, description if I want. And I can hit Create. Elastic Beanstalk lets you have environments. So if you're following a dev test live or a dev staging live, workflow, you can create different environments. I'll go ahead and make a web server environment now. It lets me specify a domain if I want, a description. I can pre-configure my platform. So I can say I want PHP here. You can see they have all different sorts of options, including if I want to go a Docker route. It's going to ask you for application code. Even if you already have your Drupal site, I just pick sample application to start with. It'll pre-configure a bunch of defaults for you versus having to try and do that with your Drupal website. And then I can hit create. Or I can configure more options if I want. I'll hit create. It runs a bunch of API commands in the back end to try and start building all of this. And you can see that it's taking a few minutes to pull it together. In the interest of time, I'm going to jump back to my existing environment here while that spins up. You can see that this is my overview page. My health is okay. It's monitoring my application, monitoring my servers. PHP 7.2 running on 64-bit Amazon Linux. I don't really care what the operating system is. All I really care about is that it's got a version of PHP that is specific to what I need and is running a web server. If I jump over to the configuration page, you can see I have the option to set all different types of things, including using a load balancer, rolling deployments, so as I change code, being able to put some code in, taking some code out, handling the updates, monitoring. If I want to include a database with it, I can also have it manage and set up my database, and it will handle all of this for me. And I can actually just jump straight to that environment, and I can find our great Drupal food magazine here. Super responsive, away we go. As more requests were to come in, if we were all to hit this at the same time, you might see the number of EC2 instances scale. So if I jump over to the EC2 section here, and I pull up my running instances, you can see that it's actually building them out here and scaling them. Here's a new one that's spinning up based on that new cluster I just created. Here's the existing one for my example Drupal testing environment. You can also see if I jump over to RDS, that relational database service, on RDS console. There we go. I have a couple of database instances in here. This FLDC demo pre is actually the AWS serverless one that's running our food demo. And it's monitoring the amount of CPU. It's got my connectivity in here. And I can even see from a monitoring standpoint exactly what my database capacity was, how many CPU cycles are provisioned, database connections, and so forth. If I were to come in back to my EC2 console, and I were to simulate a failure by deleting my server, generally you wouldn't do this, but this would be bad. That server is now going away, and I switch back over to BEANSTALK. You'll see that it recognizes this failure here in just a second and starts to respond to it to provision the next one. Deletion process takes a few minutes anyway, so that server is still technically online. But we'll switch back at the end and you'll see from the logs, the help logs, that the status went back and forth.
This thing only sets up, you can only set up one site on this BEANSTALK, right? Or can you do multi-site?
You can do multiple sites. It will do whatever you tell it
Can
to
you do
do.
multiple virtual hosts
Mhm.
on it?
Yep.
Okay.
Yeah. So if you run through the tutorial, and you can see that the status actually switched to severe here because my website just went offline because the server disappeared. When you run through the tutorial for setting up a highly available Drupal instance, it points you to a set of default configurations that you can tweak to handle the virtual host like you're talking about.
Okay.
While this is all well and good and we largely handled a good portion of our capacity planning, we still had to provision servers, which means that we're potentially wasting capacity as we go along. Overnight last night, I finished spinning that environment up after I landed. It was about 10 o'clock. We didn't use it again for the demo until 10 o'clock this morning. That's 12 hours of wasted capacity where I was paying for that AWS server. How do I handle that? One solution for that is to use AWS FARGATE. This gets into the Docker container space, but in the Docker container space, AWS FARGATE manages all of the servers and infrastructure it's running on for you and spins it up and down, similar to your AWS serverless. You run containers without managing servers. Again, no need to worry about patching, updating, hardware failure. You just pay per CPU and memory used without having to wait for the servers to spin up and spin down. AWS manages that for you. Downside of all of this is you are working in Docker land, which means we've now gotten significantly more complex. I'm pretty sure there was a Docker tutorial yesterday and some more talks throughout the weekend. The other piece to remember with AWS FARGATE is that there is no uploaded shared file system. It doesn't have support for mounting elastic file system drives at the moment. So you're going to have to handle that completely within your Drupal application for that shared file system. The way we handle that is actually using this S3FS module, which is available for both Drupal 7 and Drupal 8. It will upload all of your files to Amazon S3 for you that go to the site's default files directory. Makes installation of Drupal a little tricky because you've got to add the module as Drupal is installing, but it is doable and functional, and I will briefly just show you that it exists. Again, I search for FARGATE, which technically falls under ECS. You can see here in my clusters that I have an FLDC Drupal demo running my Drupal service. The first time you come in here, it will actually walk you through all of that. Since I have one, it won't let me go back through it. But just know that it's relatively easy. There's Get Started. It's a 4-step process to walk through defining your container definition, task definition, service, and cluster. All you really need to know is that you specify your Docker image, and then you just keep hitting next until you get to a Drupal installation screen. And then I can walk through all of this here. Takes a few minutes to spin up now. In the interest of time, since I'm about to get kicked out of the room, we'll keep rolling. Amazon has 2 other container solutions that you should be aware of. You saw that FARGATE was part of what it calls ECS, which is their Elastic Container Service. They also let you bring your own virtual machines to Elastic Container Service and run your own EC2 instances. Through that, you can mount EFS drives and put them into your Docker Drupal containers so you have a shared file system and you don't have to mess with S3. They also have Kubernetes, so if you're looking to go the Kubernetes route, they have a managed Kubernetes service. Personally, I would not recommend the Kubernetes service. If you're going to go Kubernetes, try and go the Google Cloud route. You'll find it is significantly cheaper. AWS Kubernetes is 20 cents per cluster, plus then you pay for each server that's part of your system. I've seen AWS Kubernetes clusters easily get into the $2 to $3 per hour for small sites. When you multiply that by 750 hours in a month, we're now talking $1,500 to host that simple site. If you're going the Kubernetes route, go to Google Cloud. They charge you significantly less, and it's so much easier. And it's all Kubernetes under the hood anyway. Looking at what we talked about in our different pillars, moving towards the FARGATE route where we don't have to worry about performance efficiency, capacity planning, cost optimizations. It's going to give you the most compliance with AWS well-architected framework. AWS Elastic Beanstalk is probably what will help you get there and be use most of what you're familiar with without having to go well outside your comfort zone if you're not into Docker. AWS LIGHTSAIL is if you're looking to get started with AWS and your client is forcing you to use it, but you don't want to dig into any of the nitty-gritty.
Is it hard to move up if you're in LIGHTSAIL first and then move to Beanstalk?
Is it hard to move from LIGHTSAIL to something else? Yes and no. No, it's not hard, but there is no migration path. So you're starting from scratch. Elastic Beanstalk isn't that difficult to use, especially with AWS's guide out there, which they normally keep fairly up to date with things. But you're still going to have to manually copy all your files over and copy your database. It could be a lot worse, though. It's not.
Drupal export and then import.
Yeah.
Should be.
Export your Drupal site, import your Drupal site, or take a Drush archive dump and then Drush archive restore. It will handle it for you. What I always tell people as I give this presentation and as I tell them about the different AWS services, the most important thing is to use what you're comfortable with. There's nothing worse than having a client call you because their site is offline and you have no idea what to do to fix it because you're using AWS FARGATE, but you're not very familiar with Docker. If Docker isn't your thing, stay with more of the Elastic Beanstalk route or the AWS LIGHTSAIL route. It's going to let you best serve your clients. And then set it as a goal to learn and eventually move into the Docker space as you get more comfortable with it. If you have any questions, I don't think the next talk is till 11, although technically my talk was supposed to end 5 minutes ago. I'm happy to stick around. If you're looking for me, feel free to stop me throughout the rest of the camp. I will probably either be in a couple of talks, or if I'm not in talks, I'll be hanging out at the front couches. Please interrupt me. At most, I'm doing work that I didn't get done yesterday as I was trying to get out the door to get down here. So if you stop and talk to me, you'll keep me from doing work. That's not a bad thing. I'm happy to help you with whatever AWS challenges you might have, or if they're Drupal specific, or even something else specific. I'll try and help you as much as I can. Thank you. Are there any questions before I cut off the recording? All right.